Okay, class, we're about to start the sections here. Section 1-9. I have my paper here. So for 1-9, you were supposed to do pages 87 through 89, problems 1, 3, 5, and 6. And this is in your textbook. And then we also have 1.10. So 1.9, it says write the following linear equations in slope-intercept form. Determine the slope and vertical intercept of each line. Now, one thing that we need to get familiar with, and that is the terminology. Vertical intercept is equal to the y-intercept. And we know the y-intercept is when x is 0. So that is our y-intercept. So when it says vertical intercept, it's saying y-intercept, and we know the y-intercept is when x is 0. So x would be 0, and then y would be some other value. Okay, so now we look here at 1a. We have 2x minus y is equal to 3. Now, they want us to write this in slope-intercept form. And I should have wrote this up here, but I will write it below. Slope-intercept form is y equals mx plus b. So they want us to take this equation here and get y by itself. So we have 2x minus y equals 3. We can add y to both sides. 2x is equal to y plus 3. Subtract 3 on both sides. 2x minus 3 is equal to y. And we know that that really is y equals 2x minus 3. Now, it also asks us to not only write it in slope-intercept form, but they also want us to write what is the slope and what is the vertical intercept. The slope is 2 because the slope is connected to x. And then our y-intercept is this negative 3, but we write it as an ordered pair. So that is our slope and our y-intercept. Okay, next, we move on to B. Okay, B, we had x plus y is equal to negative 2. Subtract x on both sides. Y equals negative x minus 2. That is our slope-intercept form. The slope here, we have a negative x, so we know that's negative 1, because that's what's connected to the x. Then our y-intercept would be 0, negative 2. So now we move on to C. We have 2x minus 3y equals 7. We can subtract 2x on both sides. Negative 3y equals negative 2x plus 7. Divide each side by negative 3. And I would do each individual term here. And we have y is equal to 2/3 x minus 7/3. So your slope would be 2/3. And your y-intercept would be 0, negative 7/3. So this would be your full answer. All right, now we move on here to D. Now D, we have negative x plus 2y is equal to 4. So we can add x on both sides. And we have 2y is equal to x plus 4. We divide each individual term by 2. So we have y is equal to x over 2 is the same thing as 1/2 x. Plus 4 divided by 2 is 2. So now our slope is 1/2. And our y-intercept is 0, 2. Okay. Now we come here to E. Now E, we have 0x plus 3y is equal to 12. Now, I don't know why they put 0x, because 0x is really 0. But I guess they want you to have a place value with x. So we can subtract 0x on both sides, which we actually didn't need to, but we had 3y is equal to a negative 0x plus 12. Then we could divide each individual term by 3, and y is equal to, now, I didn't do this initially, but you cannot have a negative 0, it's just 0. So 0 divided by 3 is 0, so this would be 0x, and 12 divided by 3 is 4. So this is considered to be the slope-intercept form. But it should actually be y equals 4, but they put the 0x here, so we're going to go with that. The slope here is 0, and then the y-intercept will be 0, 4. So this right here would be your answer. All right, so that took care of problem number 1. Now we move on to problem number 3. Now with number 3, it tells us to sketch the graph of the vertical line through negative 2, 3. All right, so now if they ask us for a vertical line, we know a vertical line goes straight up and down. So with that being said, they used to have a marker on here, but it doesn't look like they have a marker on here anymore. Okay, so with that being said, I'm going to draw a small little graph here. So they tell us to plot negative 2, positive 3 to be about here. Negative 2, positive 3 according to my graph. And then we're supposed to draw a vertical line from this point. Now, if you notice here with this vertical line, that would mean no matter what y is, x is going to remain the same. So, with that being said, it says sketch the graph of the vertical line through negative 2, 3. So this would be 3a. And then we will have negative 2. So actually, this line here, you don't have to write this, but this would be good for you to know. This line here is really x equals negative 2. Okay, now we move on to B. Now B says, does the graph represent a function? It'll be no, because it does not pass the vertical line test. And I'm going to abbreviate that with VLT for vertical line test. Okay, C. It says write the equation of a vertical line through the point negative 2, 3. Now we already wrote that here when we did the graph. So it'll just be x equals negative 2. All right. So now we come to D. D, it says, what is the slope of the line? Now, remember in our previous problem on page, let me go back here. When we did E here for 1E, you notice here our slope was 0. Now remember our answer, let me pull that back here. For E, our slope was 0, and we know that 0x is really 0, so y was equal to 4. So when y is equal to a number, then that means, well, when y is equal to a number, that means that the slope is 0. When x is equal to a number, that means that the slope, first of all, well, that means that the slope is undefined. So whenever you have x is equal to a number and no variable, no y value, that means that the slope is equal to undefined. The slope is undefined. Now we move here to E. It says, what is the vertical and horizontal intercepts on the line? So we know the vertical intercept, and we see that vertical line that we had here, the slope was undefined. And then the horizontal intercept, we're going to figure that out. Okay, so the vertical intercept, and we know our vertical intercept is basically your y-intercept. If you notice this graph here, it doesn't hit the y-axis, so your vertical intercept is just none. There is no vertical intercept. Now the horizontal intercept, it does hit the x-axis. So it hits the x-axis at -2. So your horizontal intercept is -2, 0. So vertical intercept is your y-intercept. Horizontal intercept is your x-intercept. Okay, so now that took care of 3. Now we're going to mosey on down here to number 5. So we had number 5, and I think, okay, 5 actually goes to E. Okay, it says here, you are retained as a consultant for a major computer company. You receive $2,000 per month as a fee no matter how many hours you work. So if you work 0 hours or you work 50,000 hours, you're still just going to get your $2,000 a month. Okay, so now, with that being said, it says using X to represent the number of hours you work each month. Write a function f in symbolic form to represent the total amount received from the company each month. Okay, so we know that, first of all, since we're doing a function and we're using X, it'll be f of X. So that's the first thing we know. And it's equal to. Now they tell us no matter how many hours we work, we're still just going to earn $2,000. So we know at 0 hours, we're going to earn 2,000. So 2,000 is our y-intercept, or our b, according to the y = mx plus b formula. Now, our slope, remember, we're not going to get paid anything more than the $2,000. So our slope would be 0. So we would have f of x is equal to 0x plus 2,000. But again, like I told you all before, 0x is just 0. So we'll just write f of x is equal to 2,000. So that means that y is basically equal to 2,000. Now we go here to B. And just to let you know, that's the answer for A. We go to B. It says complete the following table of values. We have 15, 25, and 35. Now, I'm going to attempt to draw a quick little box here. And I'm just going to put hours worked, because you all can see on the screen what it has per month. And then I'll put fee, and we know it's per month. So it's 15, 25, and 35. Now remember, no matter how many hours you work, you just get $2,000. So no matter how many hours you log, you still only get $2,000. Okay, now C. It says using your graphing calculator to sketch the graph of this function. Now, if you notice here, down here at C, where they usually would use the TI calculator, but we're basically using Desmos here. So we're going to pull up Desmos, and we're going to type in y is equal to 2,000. Now you have to narrow this in a little bit. And then now you see the line. the horizontal line. Y is equal to 2,000. Okay, so now that would take care of C. Now we come here to D. It says, what is the slope of the line? What is the practical meaning of the slope in this situation? Okay, first of all, we know the slope is 0. Because we saw that here, the slope is 0. Okay, the practical meaning of this is the phi does not change. So whenever your slope is 0, that means whatever you're dealing with does not change. KE, describe the graph of the function. So basically, what we saw here on Desmos, you notice it's a horizontal line at y equals 2,000. So you could put down for E, the graph is a horizontal line through 0, 2,000. All right. Any questions? All right, and let me just tell you this why we put through 0, 2,000. Because if we go lower than x being 0, it would be negative, and you cannot work negative hours. So in all practicality, the graph will basically start at 0. And so that's why it says through 0, 2,000. Okay, now, problem number 6, I'm not going to do. I'm going to have you all do that on your own. And the reason being is problem number 6 is not difficult. It's just a little lengthy. And it goes from A through I. So again, if you have any questions on number 6, you can always ask them next class, and I will gladly take them. Okay, now we will go to 1.10. Now 1.10, we're supposed to do pages 96 to 99. All right. On page 96, we're supposed to just do problems 1, 3, and 4. Okay, problem number 1. It says plot the following data. Now what I'm going to do here, I'm going to do this on Desmos. But you all could write this actually in your textbook. Okay, on Desmos, I will add a table, and then I would type in the x values. We add 0, 3, 6, and then it'll start populating, and then we'll go to 18. Then 0 is a negative 0.8. What's that? 6.3. 13.1. 19.6. Let me see, 27. 33.5. And finally 40.8. All right. And we have these values in here. Okay, as you see here, they look like they almost form a straight line here. All right. So we have our graph. And it says, with a straight edge, draw a line that you think looks like the line of best fit. Does this data appear to be linear? Now, if you look here, you draw a line here, it'll be almost a straight line. It's just slightly off. So I would say yes, it appears to be linear. And you all could draw it with your ruler. So this would be 1B. And then I would say yes, the points are very close to a line. Okay, now we come here to C. It says use your graphing calculator to determine the equation of the regression line. Write the result below. Now, some of you already know how to write this as a regression, and we're doing linear regression right now. So I'm going to show you, if you don't know how to do a linear regression, this is what you would do. First of all, you need to know the slope-intercept form, which we know is y equals mx plus b. Okay. Now, we have to tweak this a little bit for the Desmos calculator. First thing, if you look here at your graph, you look here at the x and y, you notice there's sub 1s there. So you will have to put the sub 1 on the y and the x. Next, you notice here that this went blank. What we have to do here now is take out that equal sign and hit this tilde here. Now, once you hit that tilde, you notice here that it's drawing your line, and it went through those points. Now, to get the graph or the equation that you're trying to get, you notice here that your m is 2.29881. We're going to round to 3 decimal places here. So we will have y is equal to 2.299x minus, we add a 0.761. It gives us our slope. It gives us our y-intercept. So this is what we would write. Now, of course, since we're doing this in function notation, based upon here we have f, x, and f of x, we would change this y to a f of x. Just to keep consistent with the problem. Okay, D, use your equation from part C to predict the value of y when x equals 10. Now, there's a couple ways you could do this. You could take this equation, put 10 in for x, and then solve it, and you will get what the f of x is equal to. Or you could actually put this here. Let me go here to the Desmos. You go back up here. Well, no, we shouldn't do it like that. Okay, so what you could do is this here. If you want to make this a little easier for you, you could type in y is equal to the 2.299x minus 0.761. Okay, now you see this here. You could go up here to this wheel here, and you could hit the graph here to make a table. You type in the number 10, and it kicks out your answer. It'll be 22.229. So D would be f of x is equal to 22.229. Now, the reason why I did that is because typically you get more problems just asking you for those points. So if you just type in that equation, do a table, you could just put the points in there, and then it will automatically kick out the answer for you. So if we look here at E, E says, use your equation from part C to predict the value of y when x equals 25. So we could go right back here to our Desmos calculator, type in 25 for x, and that would give us 56.714. All right, now it says, which prediction, f of 10 or f of 25, would be more accurate? Explain. Okay, let me show you this here. Let's look at the original points. When we go up here to the original points, we stop here at 18, right? Okay, so basically f of 10 would fall in between these points here. So that is called interpolation. Interpolation is basically points that are within the original values you had. X being 10 is within the values you already had. Extrapolation is when you have values that's outside of this here. Like for instance, x being 25 would be extrapolation, as it said. So with that being said, so that's f. F of 10 would be more accurate because it is within the given data. Then you could put in parentheses, interpolation. Okay, so, and we know f of 25, and we could say f of 25 is not. And then that'll be extrapolation. Okay, now that took care of problem number 1. Now we move on to problem number 3, to be on the next page. Oh, wait a minute. Maybe it's at the... Okay, problem number 3. Yes, it's at the bottom of the next page. All right. It says in 1966, the U.S. Surgeon General's health warning began appearing on cigarette packages. The following data seem to demonstrate that public awareness of the health hazards of smoking has had some effect on consumption of cigarettes. So we see here this table. Now, we go over here to the next page. It says A, plot the given data as ordered pairs of the form T of P, where T is the number of years since 2000 and P is the percent of the total population, 18 and older, who smoke. Appropriately scale and label the coordinate axis. Okay, I have to take this time out. When I was in one of the rooms, I have to say this here. I thought they wanted us to go back to 1966, so I was in error with that. They wanted us to go back to 2000. So when we go back here to get our points, we need to look here at this table and act as if these are years since 2000. So according to that table, there's only going to be a slight change. So 2001 would be 1, 2003 would be 3, and then we'll have 5, 7, 9, 11, 14, and I think the last one is 15. Yes, 15. Okay. And then we would have 22.8. These numbers don't change. 21.6, 20.9, 19.8, 20.6, 19.0, 16.8, and 15.0. Now, we have all these values, and it's since 2000. So they wanted us to plot these values here. So on our x-axis, which in this case would be t, we know that this is the x-axis, and then p would be our y-axis, and you would plot those points. Now, what we're going to do, I'm going to put this in Desmos. So what I'm going to do is this here. I'm not going to get rid of this second line, but I am going to change this graph here. All right, so it'll be 1, 3, and then let me see, 5, 7, 9, 11, and then we have to change 13 to 14, and then the last one would be 15. Now we go back up here, put in these values. We got 22.8, 21.6, 20.9, 19.8, 20.6, 19.0, or you could just type in 19, 16.8, and then also 15.0. All right, now we could turn off, let's see, we could turn off this, well, no, we could leave that. So it's really this red one. We could turn off this red graph here. So this is our graph of this line here. This is our best fit line. And you notice since I didn't change this here, everything changed when I changed this data. So it gives you the new slope and a new y-intercept. So with that being said, your equation for B would be y equals mx plus b. We're substituting the variables. We have P is equal to MT plus B. And then we would substitute. P is equal to the slope is a negative 0.48. We're just rounding 2 decimal places here because it tells us to do that in B. T plus 23.48. So that would be our equation. Now we go here to C. With C, it says use the equation to predict the percent of the total population 18 and older who will smoke in 2025. Now remember, we did everything since 2000. So 2025 will be 25 years from 2000. So since we only have one question here, we could just substitute in 25 for T, because that's the years since 2000. And we can add 23.48. And then when we add all of these, when we do our multiplication and our addition, our P would be 11.48. So basically it's saying here that approximately 11.5, so approximately 11.5% of the total population (18 years of age or older) will smoke in the year 2025. All right, now I'm gonna have you all do number 4 on your own. Like I said, I would do most of the problems, but I still will require you to do some on your own. So basically, we are done for the 1.9 and the 1.10. And if you have any questions, feel free to contact me. Have a wonderful, wonderful day.